To derive the sine rule, first we have to introduce right angles to this triangle so that we can apply trig or trigonometrical ratios. So we have our first triangle. We'll introduce another one later on. So let's just focus on this one now. So let's just call the length of this height x, and let's introduce new terms as well to segment, which will make which when we add together they should be equal to b. So we know that b is equal to m plus n. Okay, so trigs, we know from trigs that sine angle is equals to opposite over hypotenuse, right? So that's what we are going to apply to arrive to this final formula. So let's start with C. We can say sine C, angle C, is opposite is x over hypotenuse. Our hypotenuse is A, and we can do the same with sine A, and sine A is opposite as well over hypotenuse C. So these are two different equations. We have equation 1 here and equation 2. So since these are two separate equations, so to link them together we have to find something which is common between them, and that common term between them is x. So let's just make x a formula and equate one to another. And for the first one, x is a sine c. If we cross multiply each term here, we will have this, and we also do the same for this other equation, and we are left with x to be equal to c sine A. Okay, well, since we find that something which is common, we can actually equate these two expressions. So we have now a sine c to be equal to c sine A. Okay, since we have something which is common, let's divide everything by everything by sine A sine C, by sine A sine C. Okay, so when we divide what's common within the two. Oh, sorry, we just divided the wrong term. Okay, so this will give us A over sine A to be equal to C over sine C. But it's not yet complete because we haven't got sine B. So we haven't got the term B over sine B. So to get that term, we have to introduce another. We have to rearrange our right angles now. So let's introduce another right angle. Let me just put it here, but let's just assume it will be right angle. Let's just say this is a right angle. Okay, and let's call it the height of this line y. And let's introduce also new terms here. We are just approaching it the same way we approached the first time when we determined A over sine A is equal to C over sine C. So the new terms we can say M and O. We can say we can call this C and we can call this P is T. Okay, from here to here it's P, and from here to here it's C. So we know as well as we did here. Let me use a different color. So we know this is our C. We know C is equal to P plus Z. Okay, so we are applying this same formula as well sine theta is equals to opposite over hypotenuse. So let's start with so this is our angle. This is our angle. So we start with A, right? And this is its opposite, and this is its hypotenuse now. Okay. So let's start with A. So we can say sine A is opposite, and the opposite is this angle, which is directly opposite to it, which is y over the hypotenuse is B. And we do the same with B, because it's corresponding to this new height which we just introduced. So we can say sine B is equal to y as well, but it is a different hypotenuse, which is A. Okay, so we have equation 1 and equation 2 as well. So what we do is what we did previously. Here we have to find what's common between those two equations, and then we equate each term to the other. So let's find what's the common link between these two equations. So we just cross multiply each term, and when we cross multiply, we have to make y a formula, because y is what's common between the two. So for this first equation, we have y is equals to B sine A, and for this second equation, we have A is equals to we have y is equals to A sine B. Okay, so since these two terms are equal and the same, we can actually say B sine A is equal to A sine B. Okay, and we can even divide by sine A sine B sine A sine B. What we are doing on the right hand side is what we are doing on the left hand side, so to make sure our equation is balanced. So this one is the same as this one, and this one is the same as this one. So we can actually conclude that B over sine B is the same as A over sine A. Okay. So what did we get? But first, we obtain this result, and now we obtain this result. And this is equation, let me just call equation 1, and this is equation 2. Okay, since these are two equations, as we did with the other expressions or equations, we have defined what the common link between these two equations, and then we have to link them together. So the common link is A over sine A, or A over sine A. Because that's the common link, we can actually deduct that A over sine A is equal to B over sine B is equal to, because we know that this is the same thing, and we know that A is also equal to C over C. So we can actually say C over sine C. So this is how we have derived. Okay, this is how we have derived our final sine rule. So I hope this was helpful, and please comment and also subscribe to my channel. Thank you.